Hello guys, I'm Igor, and today I'm gonna present my implementation of the Typeahead API. So basically the Typeahead or autocomplete is the implementation using lots of websites and softwares, mainly into search features. So it's a optimized way to perform searching based on prefix. So as you can see here, we have a bunch of data in this format. So here we have a file with lots of names. In these names we have also the times attribute or popularity. So basically is how many times this name was searched across the application. Okay, so just to show you the project structure, basically we have some main files. The first one is the .env file. Basically here we set up three main parameters. The first one is the port that in which the application will be running. The other it is the host the application will be using, and also the suggestion number. So basically the suggestion number is the number of names that will be displayed in our search. Okay, so talking about the framework and also technology used in this implementation, we use the Fastify framework. So basically the Fastify framework is a JavaScript library similar to the Express, but a library that looks forward to be more optimized and also simpler than the Express. Also, it relies on lots of plugins and adapters, so it's pretty interesting. So I adopt the Fastify because first of all I'd like to try it because I already have experience with Express, so it's a good practice to always looking for new ways of doing things, so that's why I use the Fastify. And also because to the nature of this project, it's pretty simple, so I feel that using a lightweight library would be the best approach. Okay, so talking about the code itself, here in the config file, basically I do the handler of the variables that I set up here in the env and also export them for the entire project, as you can see here. And the application itself starts here in the index file. So here basically I do the import of three things. The first one is the Fastify library, then the service where the actual implementation of the project is done, and then the variables defined in the .env file. Okay, so as you can see here, this is the way of instantiate the Fastify library. So basically here I define that I want to have the logger in the as true, and also that will be ignoring the trail slash, so this character. Okay, then I register my service, so the application will know that I have some endpoints, the route of the application. So basically we have two main endpoints. One get, so if we type the address of our service /typeahead/ a prefix, basically the application will understand that we want to look for names that has this prefix is in the beginning. Also we have the post /typeahead. So basically here we are saying, okay, we want to update the popularity count of a given person. So in this case, when we run this endpoint and pass Joanna as the parameter in the request body, we are telling the application that we want to increase the Joanna popularity by 1. Just a heads up, when we do this update, it will be persistent just while the application is running, as defined into the readme file. So if you kill the application and run it again, the Joanna popularity will go back as defined into the names.json file. Okay, Now, talking about the endpoints implementation, let's head to our service file. So here we have some imports. This one is really interesting since the Fastify plugins allow us to extend its features by adding routes, server decorators, or whatever we want. So I make use of this functionality to implement our routes using Fastify. Okay, so basically here we have some basic definitions of our prefix tree. I'll be explaining the implementation of this tree later on. So here we have the instance of the prefix tree. Also here we have all the list of names sorted by its popularity, so in a descending order. And here we have the list of available endpoints. This first one is basically a way to let the developer know that the application is running and working. So if you type this, the server URL, you will see the hello world message. This one, just the server/typeahead without any prefix, is basically a way to handle a edge case in which the user does not pass any prefix or pass the typeahead without the slash. And this tool here is actually the implementation we need. The first one is a get receiving the prefix. So here we receive the Joe, and by using this prefix we can see the results returned by the API. So let's run the application. With the application running, we call the endpoint and pass the Joa prefix. So here you can see we receive the results of names that start with Joe. So we have some here, and you can see that they are descended, sorted by its popularity. Okay, so diving into the implementation of this endpoint, basically here receive the parameter from the query string, and then we convert it to the lowercase to make sure we handle all the in a case insensitive, because we, as described in the region file, we can pass lots of different combinations between upper and lowercase letters. So just make sure we normalize it in the same way. Here we perform a search into the try. I'll explain specifically each method from the try later on. And then we map each result if it's corresponding popularity. And then we sort by popularity, and then we return the results using the reply.send method. Okay, about the post endpoint, here we have some more details because we need to handle some edge cases. Like after receiving the request body, we get the username, and if we receive a empty name, we need to return the response with the 400 status, so the user can see that the request is invalid for some reason, so it's a better feedback for the user. Also, if we perform the lookup in the tree and we didn't receive any response, we also return the 400 status. Otherwise, we are able to find some name with the object passed into the request body. We perform the popularity incrementing by 1, and then we return the object, the name object, with name and also popularity, and then we finish the endpoint. Okay, now let's see the post endpoint working. I'll actually change the Joanna popularity. So in order to do that, I'll call the post, pass the actual URL of the post endpoint, and as the body request, I'll pass the Joanna. Okay, so here you can see in the actual state, Joanna has the popularity of 440. So after running this endpoint, the new popularity should be increased to 441. If I repeat, we have 442 and so on. Okay, so now we can head into the PrefixTree implementation. Okay then, so the final part of this screencast is the implementation of the PrefixTree. So here we go. So basically here, before the definition of the PrefixTree class, we have the definition of a node. So basically our node is composed by a list of children. The key is key boolean. Basically this attribute means that the given node is a complete word, in our case a name. Also a value. If we have a complete word, we have it right here in the value attribute. And also a data attribute that we receive a template variable. In other words, you can receive any value. But in our case, we are using it to represent the popularity, okay? So probably it will be a integer. Here in the definition of the PrefixTree, we also receive a parameter as our template variable, and here we define the root node as a node, a PrefixTree node, receiving our parameter with key and children empty by now, in which children will be a empty array. Also, our class come up with some public and private methods. So here we have the insert, lookup, search, and also get descendants. Talking about the insert method, we receive two parameters, the key and the data. So basically the key will be the name that we want to insert, the whole string, and here the data, the popularity. So the first step, we put a pointer into the root node, and then we iterate over the key string. So for each key, each letter of the string, we'll be adding a node into the children of the current node. So basically here, since we start with the root, because we have a pointer, node is a pointer for root, we check if we already have child with the current key. If not, we'll be adding it like this. So here we add the child with the current key, and we open a array of children for the current child, okay? And we do it the right way because it's easier to understand the implementation. Also, we have the lookup function, and this function is designed to return a given node according to the key. So, for example, if we call the lookup with Joa, like we had in the previous example while running the endpoint, this function will return the node representing Joa, and it's different from the search method since the search will try to look for exactly matches for Joa. So, in other words, all the names that has Joa as the prefix. So here, lookup returns the node, and search returns all the matches for a given prefix, okay? So here we have something similar to the insert. First of all, we create a pointer for the root node, and then we go over all the characters of the given key. So for each char in this iteration, we check if we already have a child with the current key. If not, we return no, because it represents that we don't still have the name in our tree. So if we don't have the name in our tree, we don't have any node to return. So basically that's the validation. And at the end, we check if we were able to find the matched word for our key, and then we return it, okay? Here in the search method, basically we do something similar, but the difference is when we reach the last character in the prefix, like in this case the last one will be the letter A, we'll need to go over its descendants because we are trying to find all the correspondence for Joa. We could have Joan with one N, Joan with two N's, Joanne, Joannis, and so on. Okay, so basically it's what these get descendants do. It gets the prefix and go over all the possibilities we have from here. I think with that we finish our brief introduction of the Typeahead implementation and hope you could enjoy it. Thank you.